When you're thinking about microcracks, you want to be able to identify them and see them. You can see them in the factory. You can see them in the field. There are two critical ways of seeing them in the factory. One is to do what's called offline testing at the interconnect machine. And this is where you're checking on that critical process to make sure the process is not causing damage. You pull the wire off the cell and you measure the force and you look what's left behind. And if the force is not in specification, if what you leave behind is not what you expect, then you know that your machine's not working correctly and you can adjust. So that's the first thing. That's really looking at the source. Once the cracks are in the cell, you have a technology called electroluminescence imaging. And in this case, instead of putting light into a solar module and getting electricity out, you do the reverse. You put electricity in and you get light out. And the light that you get out is in the infrared range. So if you use an infrared sensitive camera, you can see it. It looks a bit like an X-ray. It's a black and white image, but what makes it very valuable, similar to seeing a problem in an X-ray, you can see a problem in a solar cell. You can see problems with soldering, you can see problems with wafers, and you can see cracks. And being able to see these cracks allows you to identify cells with cracks and to repair or replace those cells before the module is finished. That helps avoid ever shipping a microcrack in the first place. You can use that same technique, electroluminescence imaging, when you receive the modules or after you install the modules or at any point during the process or during the life of the module. You can always take an electroluminescent image and look at the image and look for cracks or any other kind of defect in the wafer or the cell.